So yeah, I kind of made the mistake in my math file in Minecraft. So since I don't want to narrate this full thing, I'll probably have the text to speech narrator. Um, what's his name? His name's Michael.
So yeah, the first learning target is literally just the word parallelogram, so I'm just going to build a parallelogram just to explain it and stuffs. So as you can see, the opposite sides are congruent because you can count how many blocks there are, and they are congruent. Because the sides are congruent, the angles are also congruent, and if the TTS narrator mispronounces half of these words, just know it's not my fault.
So now I'm going to try and explain this as the voice because I don't like TTS explaining things. So parallelogram is it has two sets of congruent sides similar to a rectangle, and their opposite angles are congruent. So as you notice, this angle right here, when compared to this angle, if I would just flip it over like that, it is the same angle. And same thing for these over here. They have a small angle of like if I were to measure the angle by counting the distance from 2 blocks over of the vertex and then going downward, this would have an angle of 2, and this would have an angle of 2, and then for this one, it would have an angle. I forget what I was trying to do here, but it works. It has the same angle here, and I can prove it because if I were to go 2 down, 2 over, I would make that shape. And for this one, if I were to go 2 up and 2 over, it would make the same exact shape. As you can see, it has that little curve there, and it has the little curve there, which proves that they're the same angle.
So the next LT is triangle similarities, and there are a few types of them. The main types are side, angle, and angle, and side. There is also hypotenuse leg for right triangles.
The only real triangle similarity I can show within Minecraft without it getting too complicated is hypotenuse leg. The diagonal side being the hypotenuse in both of these triangles, and I can tell that they are congruent because I can count 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since I can also tell that the bottom sides are equal, so if I were to / copy, it says 12 blocks affected. If I were to do this here, / copy, it also says 12 blocks affected. So this shows that, and I can, if I were to actually plug these into for the equation for triangle area, they would equal the same amount. So for whatever reason, OBS doesn't like to capture just Windows Paint. So if you see my editor, say hi. Basically, I'm going to try and explain a few triangles. So we have a line. I'm going to make another line. And now we have a triangle, apparently. So I'm going to prove
Side, angle, side.
So these two triangles, I know they're congruent because I copied and pasted the same exact one. However, if I were to prove that they were congruent, all I would need is a few things. A side, another side, or I would need a side, another side, and then an angle that would be in between them. The reason this is because if I were to take a side and another side, come on, Windows Paint. And then The side links are locked in place. They're not allowed to change. The side links are not allowed to change. However, the angle in between them can. So you can have the same side links and have a different angle, and that no one would care because it's not congruent. And this angle, this side right here, would be different. But once you lock that angle in place, no matter how long this side, it will always be the same length in between from here to here. So with these two triangles, also have a single angle that is locked in place. So we can prove, once we are able to prove that these two are congruent having the same angle, we can prove that these two are congruent by some random mean measure. Like, let's just pretend that we know this equals 7 and this equals 9 and this equals 3. So, yeah, and now this side is locked in place. No matter how big we make this line, the space that this angle covers without these two sides changing will always be constant. By the way, I'm editing these as I go, and I now realize it's at angle, so I'm going to do that this time. If you have an angle here that's congruent to this angle here, and you have another angle that corresponds to that angle that's also congruent, the lengths of the sides can't change. So if I were to go like this and this, if you were to have the length of this angle here change, it would make the length of the third side change, and it wouldn't be congruent. If you were to take two angles, however, the lengths of the sides can't change. Because if this side were to become bigger, so let me actually do a different demonstration. If you were to have this angle here, okay, we have like this angle right here, it covers a certain amount. This is the angle here, and this is the line that would go in between the angle in order to represent how much area the angle covers, or more like one-dimensional, but how long the space in between the angle. In order for this line to get bigger without going backwards, it would need to increase the angle and make a new one. So let's say this angle is now this big. It would now make the line this big. So if the angles are locked in place, then you can't change anything else, and they are congruent, I think. Oh, hi, Discord. So I'm going to show you why side works in Inventor instead of Paint, because I don't feel like Paint. Wait, what the heck? Something that works. So I'm gonna do something. We can dimension this and find out the angle. But I don't want to do that because I'm not even doing angle. Can I not delete dimension? Okay, thanks. So, side, pretty obvious. Kind of just take the side lengths. We know their dimensions. And since we know that they're the same on all three sides, we can determine that their area... Can I not get a diagonal dimension? Whatever, but... Could determine that their area is congruent. If I can get a side one, that would be nice. Okay, no. Can determine that their area is congruent. But I'd like to review. For this one, I'm going to be trying something weird. So I'm going to be doing trig ratios, except for the fact that they're going to be side by side. So the basic things are SOHCAHTOA and then TOA. I can draw. Basically, in a triangle, you have the angle theta, and let's say this angle is 25. The sine. Oh wait. Whatever. Pretend this is the smallest side, but basically, let's pretend this is the hypotenuse. Actually, so. No, this one is going to be the hypotenuse. I'm changing my mind too much. So, what I'm going to do is I want to find the length of this side right here. So, I would do sine of 25. So that would be is equal to, so TOA, or sine, which is opposite over hypotenuse, which would be x over a number, 25, right? Or I need to give this a value. We're going to give this a value of 9, because why not? Is equal to x over 9. In order to solve for this, we multiply the 9 out of x, and and then we change it out, and we put 9 over here instead. So, 9 times the sine of 25 equals 3.8, or roughly 3.8. For cosine, you would do the exact same thing, except you would change the ratio to adjacent over hypotenuse. So, let's pretend this length is 7. Or, no, we don't know this one. So, we would do the cosine of 25 would be the exact same thing because it's adjacent over that. So it would be the cosine times 9, which would be 8.1, which gives us a different ratio. The tangent of 25 would be different from these previous ones. So the tangent of 25, this angle 25, would be if we wanted to solve for the hypotenuse, and we wouldn't know that. So let's pretend this is 3 and this is 2. So it'd be the tangent of 25 times TOA, opposite over adjacent. Adjacent over... Okay, so actually, never mind. This isn't 3 anymore. That's theta. So we put 2 there. Adjacent. So 2... So then we have x over here, actually. So we have x times that equals 2, since we multiplied out x. Then we have to have the tan of 25 actually here. We divide out the tan of 25 from x, and that would give us 2 over the tan of 25 is equal to x. And whatever that is, 4.28, would be the thing. So now if we want to find out the angles instead of the thing, so if I don't want it to be, if I want to solve for the angle theta, I would use the inverse of these trig ratios. So let's use the cosine, for example. Let's pretend this is the hypotenuse again. So also for TOA, the adjacent is never the hypotenuse, because no. But let's pretend that this is the hypotenuse and we want to find the sine. So we know this is 7 and this is going to be something bigger than 7, 11. We would do negative sine 7 over 11, which would give us the angle 39.5219636789101112. But if we wanted to do the same thing, except for the cosine, which would be the... I just realized that was the cosine. So if we wanted to do the cosine, let's actually pretend. Let's pretend that these both equaled 7, because why not? If we wanted to do the cosine, we would do the exact same thing, and 7 over 11. However, it would give us a different output because it's the cosine ratio instead of the normal one. If we wanted to do the tangent, we would do 7 over 7. And that would give us an exact angle of 45 because you would know, which actually is factually correct because it's an isosceles triangle. It's an isosceles triangle and pretend, well, if it was like a 45, 45, 90 triangle, then that's how it would be. Or it's like the word for that kind of triangle. Yeah.
So now I can return to the magical world of Minecraft. The last two learning targets are very easy to show in Minecraft, so I'm going to be doing that RN.
So what we have here is a circle, with the center being a diamond block. I have given it a radius of 5. So if we wanted to, 1, 2, 3, 4, 5, to the center, which I had as a diamond block slash center diamond block. Oh, wrong thing. Basically, this is a circle. You can get the area of the circle with the classic equation pi r squared. And you can find the center of it by taking points. You can take any 2 points that you can. You can take the endpoints of a diameter and you can average them to get the exact center of the diameter, which would be your center point. So with this center point, we could also determine if certain things would be on the circle. So we wanted to find if something was on the circle. We would use the equation. Oh, yeah. You can just take the equation x plus the center. So let's assume the center is actually 0, 0. So let's assume the center being 0, 0. We want to see if something is on the circle. Anything to get from the center to the from the center to the outside, since it has a radius of 5, it would be 5 off. So if we wanted to, it would have to equal 25, not the radius. I'm in a dot. So now that we know that I just relearned this learning target in about 3 seconds, I can actually do this. So if I were to take the point, let's go up to the right 2. I could say that that is not on the circle simply because there are blocks there and the blocks don't line up with these blocks. Or I could say that these don't line up. That point right there up y plus 2 minus y plus 2 and y plus and x plus 3, because 2 plus 0 squared plus 3 plus 0 squared does not equal 25, and therefore wouldn't be on the radius of the circle, or on the circumference of the circle, more rather. But if I were to let's say, oh no, let's go like this, right? Yeah. Okay. Oops, I meant to slash copy like this, and I were to move 1, 2, 3, 4, 5, 6 blocks over, and if I were to slash paste, the entire circle would move with it. So that one being the old center, the entire circle would move with it, meaning that if you move the center point, you would move the entire circle. And therefore, now that you would have x, so you would have your x plus 6, and then you would have your y plus 0 squared, and x plus 6 squared, y plus 0 squared, to see if it were to equal 25, and if it does, then you can declare that that point would be on the circle.
So the next LT is volume, and that's really easy because Minecraft ES square.
So in order to find the volume of things, let's make a basic rectangle with pause 1, pause 2. I want pause 2. Oh no! Come on. Okay. Set bedrock. So this is a rectangular cube. Rectangular prism, basically. So it is a cube. So in order to find the length, you would do the length times the width time. So you do the length, which would be from here to here, times the width times the height, which would be going down. So if I do slash cut, there are 4. That was a square cube of square. And 48 blocks. So the next shape would be a cylinder. Would be slash CYL diamond block, radius 6, height 7. Oh, gun. Cool. So now we have a cylinder with 6. So you see all of these blocks here. That entire thing is being multiplied every single layer. So we'd have the radius slash center, actually CYL gold block 1, and it would make the height 7. Didn't expect that to happen. Whatever. So let's assume that this is the center or something. That is not the center. Let's say the center is like here. It's pi r squared times the height because it's the area of this, and assuming that one block is considered two-dimensional, the area of this circle right here times the height of it, because that one circle is being stacked on top of itself. It's almost like that one scene in Big Hero 6. And it's cool. So the next one, actually slash undo. We have a cone. This took me a little to build, and it's totally a cone. Okay, now it's a cone. If we were to go into the cone and make a cylinder in the center, this is the center, which is the center of this one. Slash CYL. Let's make it out of diamond blocks. And then we'll make the radius. I want to say it was 5, and then the height. We'll make it 8. Oh, slash undo. I meant HCYL. Slash HCYL. Diamond block. We'll make the radius 5. Height. Let's make it 10. Cool. So now we have this cylinder. It's totally a cylinder. Let's pretend that the cut So this cone right here, it takes up 1/3 of the cylinder, which means use the same equation for a cylinder, except you would divide it by 1/3, and the remaining space here is 2/3. Same thing for a pyramid. It would be the very similar thing, and it would almost be the exact same thing. For spheres //H sphere bedrock, actually, let's not make it Make it 32 radius. Now we'll make it 15 radius. Cool. This is 4/3. But this is 4/3 of the average circle. The reason it's 4/3 is because if you were to take a circle and multiply it by 3, that would just get you a whole cylinder. If you want it to be rounded out, you would have to do a little over 3, which would be the equivalent of 4/3. Now I'm done with this project, so I'm going to go edit this last segment, and then I'll be done probably by